The next part of rotation that we're going to be talking about the next 2 days in here is what we call torque. And that's going to incorporate more things related to force acting on objects. Before we can get into all the specifics with torque, we have to talk about one other thing that we dealt with at the beginning of our unit on forces, and that's center of mass and center of gravity. And we're going to incorporate a third piece, center of rotation. So if we go back to center of mass, a good example to take a look at to talk about what we're dealing with when we bring in the concept of rotation is if you look at the image with the three trucks, A, B, and C, the dots that are shown, that is the location of the center of gravity or center of mass of each of them. Out of those three, which one is most likely to tip over? The correct answer ends up being truck A. Now the reason for that has to do with where the center of mass is located relative to the base of the object. For truck A, center of mass is located not directly over the wheel well. If you look at truck B, it is located over it, and truck C also that case. Now again, this is not where all the mass is located. The dot is showing where the center of mass happens to be located, and if it's not over the base of the object, it is most likely to tip over. In just a couple minutes, you're going to break off into your lab groups and begin working on a lab that's going to deal with torque, which is force in rotation. Before you get into any of the data collection with the lab, there are two things that I would like each person to attempt doing, and those are listed on this slide: the wall bend and then the tippy toes. So with the wall bend, stand with the back of your legs up against the wall. So find a spot along the wall or the cabinets where you can put your heels and the back of your legs entirely up against the wall, and try to bend over without bending your knees or having your hips leave the wall. So your hips would continue to touch the wall and you keep your knees straight. Okay. See what ends up happening. And the second one, with the tippy toes, stand with your nose against the wall, as weird as it might sound, and try to stand on your tiptoes and keep your nose touching the wall at the same time. Okay, and see what ends up happening. Okay. A lot of this will have to do with your balance, but also the positioning of your center of gravity or center of mass. Now the final piece before we head into the lab is this basic statement right here about the center of mass of an object. Objects will always rotate around their center of mass. So the picture that you see with this wrench, the white dot is showing you where the center of mass of the wrench is, and as it's being slid across a table while rotating, you can see that the center of mass essentially moves across the table in a straight line. Now if you were to do this while throwing the wrench, what it would look like if you tossed it up at an angle, you would essentially see a nice parabolic shape for the path of the center of mass. What you would see if you watched just the wrench as a whole is a very wobbly shape to it. Okay? We'll demonstrate this tomorrow when I'm back in class, so you can see exactly what we're talking about. Now, for the next bit of time, you're going to be breaking off into your lab groups, first to do those couple of demonstrations on the previous slides, and then you're going to be working on a lab called the torque feeler. You'll find this document on the labs page on Canvas. Before you do anything with the lab with data collection, be sure to read through the entire procedure so you know exactly what you're going to be doing. But you are ultimately going to be trying to answer one specific question without knowing in advance the relationship between some of the variables that you're going to be collecting data about. So read the instructions carefully and then complete the data table and the data collection to try and ultimately answer the question. You will be ultimately trying to find a relationship between the masses of your objects, your weights essentially, and the distance from the pivot point. With the equipment you have, the meter stick is set up with a pivot point right in the middle, already set up at your lab stations. That is not going to move. Okay, the pivot point is right in the middle. When you measure the distances, you are always measuring the distance from the pivot point to wherever your masses or weights are positioned. And so if this is your lever, here's your pivot point. If I place a bunch of masses right there, the distance that I would measure would be from there to there. And if I place masses way over here on this edge, the distance I would measure to those would be that right there. Okay, always from the fulcrum or the pivot point to wherever the masses happen to be. Ultimately, you're going to be trying to find ways to get these to balance out. And that's part of the task of the lab. So read through again the procedure. You guys will have the next 30 to 40 minutes or so to be able to work on and complete this particular lab in your groups.